Hi friends, in this video we will solve question number 11 to 16 of exercise 3.2. So let's start. This is the 11th question and we have to find the value of x and y. So what do we do first? We have to do scalar multiplication. So let's go ahead. If I multiply it, I'll get 2x, 3x plus this will be minus y, and this will be equal to 10 and 5. So the next step, let us add these two matrices. So we'll get 2x minus y and 3x plus y. This is equal to 10 and 5. So please note, everywhere the order of the matrix is 2 by 1. So now the next step is that since these two matrices are going to be equal, that means that the corresponding matrix elements are also equal. So it implies that 2x minus y is equal to 10 and 3x plus y is equal to 5. So let us label this equation as 1 and this equation as 2. So if you observe, if I add these two equations, I can easily eliminate y. So let's do that. If I add 1 and 2, I will get 5x is equal to 15, which implies that x is going to be 3. So this is the value of 3. So let us substitute this value in any of the two equations. Let's substitute in equation 2. So substitute x value in equation 2. Then we will get 3 3s are plus y is equal to 5, which implies y is equal to 5 minus 9, which means y is equal to minus 4. So this is the value of y and x is equal to 3. The 12th question is, again we are given 3 multiplied by this matrix is equal to the sum of these two matrices, and we have to find out the values of x, y, z and w. So let's go ahead and do the scalar multiplication first. So we will get 3x, 3y, 3z and 3w. This is equal to, on the right hand side I have to add these two matrices. So let's go ahead and add. So I'll get x plus 4, 6 plus x plus y. Then the second row I will get minus 1 plus z plus w, and here I will get 2w plus 3. So since these two matrices are equal, I can equate the corresponding matrix elements, which means 3x is equal to x plus 4. This is one equation, so directly I will get here 2x is equal to 4, which means x is equal to 2. Great, I have already got the value of x. Now let's go to the first row, second column. Here I have 3y is equal to 6 plus x plus y. Now I already got the value of x, so let me put that. So this y, when I bring it on this side, I'll get 2y is equal to 6 plus x is 2. Which means I will get 2y equal to 8, which means my y is equal to 4. So I've got the value of y. Now we come to the second row, first column, which is 3z is equal to minus 1 plus z plus w. So here I can bring the z on this side. So when I do that, I'll get 2z is equal to minus 1 plus w. Let's keep it as it is. The second row, second column is 3w is equal to 2w plus 3, which means I can bring the w on this side. I'll get w is equal to 3. So when I substitute the value of w in this equation, friends, I will get 2z is equal to minus 1 plus 3, which means 2z is equal to 2, which implies that my z is equal to 1. So I've got all the 4 values. X is 2, y is 4, w is 3 and z is equal to 1. Friends, the 13th question is that we are given that f of x is equal to this matrix. So if you say f of x is nothing but a function in x, and in this case it is a matrix with these matrix elements, cos x minus sin x 0, sin x cos x and so on. So what would be f of y? F of y would be the same matrix, but x will be replaced by y. That's all. And what will be f of x plus y, which they want us to find? Instead of x, you will write x plus y. That's all. That is the only change that will be there. So we have to prove that f of x into f of y is equal to f of x plus y. So we just have to multiply these two matrices and prove that it is the same as this matrix f of x plus y. So let's go ahead. First let us write down f of y. F of y will be nothing but wherever there is x, just replace it with y. So you will get cos y minus sin y 0, sin y, cos y 0, 0, 0, 1. That's all. This is the matrix f of y. Now we have to multiply f of x into f of y. So this is nothing but the left hand side. Left hand side is what? F of x into f of y, which means first let us write the terms very carefully. So because that's where the maximum mistakes happen when we copy the matrix. So the f of x is cos x minus sin x 0, sin x, cos x 0, 0, 0, 1. This is f of x. Multiplied by f of y is nothing but cos y minus sin y 0, sin y, cos y 0, 0, 0, 1. So these are the two matrices. So friends, let's go ahead and do matrix multiplication. The order of both these matrices is 3 by 3. So when we get the product, that matrix will also have the order 3 by 3. So when we multiply, let's be very, very careful. So it will be cos x into cos y minus sin x into sin y plus 0 into 0. So let's write that. Cos x into cos y minus sin x into sin y plus 0. So this is the first row, first column element. Now next we have to do the first row, second column element. So we'll take the first row of the first matrix and the second row of the second column of the second matrix. So it will be cos x into minus sin y minus sin x into cos y plus 0. So let's write that. Cos x into minus sin y minus sin x into cos y plus 0. Next element is going to be the first row, third column. So for that we have to take the first row and the third column. So if you see cos x into 0, which will be 0, minus sin x into 0 will also be 0, and 0 into 1 will also be 0. So the first row, third column matrix element will be 0. Okay. Now I'll just close the brackets over here. Now let's go to the second row. The second row, first column matrix element. Let's find it out. So it will be the second row and the first column. Okay. So sin x into cos y plus cos x into sin y plus 0. Okay, this will be the second row, first column. Then you will have the second row, second column. So for that I take the second row and the second column. Please be very careful when you are multiplying the corresponding matrix elements. Don't mix it up. So you have to take sin x, second row, second column. So sin x into minus sin y plus cos x into cos y plus 0. So this will be the second row, second column. Now the second row, third column will be second row and third column. So sin x into 0 will be 0, cos x into 0 will also be 0, 0 into 1 will also be 0. So this entire matrix element will be 0. Now let's go to the third row, first column. The third row, first column element means I have to take the third row and the first column. So 0 into cos y is 0, 0 into sin y is also 0, plus 1 into 0 is also 0. So this entire matrix element will be 0. Now the third row, second column will be 0 into minus sin y, which will be 0, 0 into cos y will also be 0, and 1 into 0 will also be 0. So this entire element will be 0. Then I have the third row, third column, that is 0 into 0. This is also 0 into 0, but this is 1 into 1. So I will get 0 plus 0 plus 1. So my third row, third column element will have the element 1. That's all. Now let's simplify this further. Now cos x, cos y minus sin x, sin y. Now this is nothing but trigonometry. This is nothing but cos of x plus y. So that is the formula. minus cos x sin y minus sin x cos y is nothing but, if I take the minus sign outside, I will get cos x sin y plus sin x cos y, and this will be 0. Now if I see down again, it is sin x cos y plus cos x sin y, which is nothing but the expansion of sin of x plus y. Then the second row, second column will be cos x cos y minus sin x sin y. So that is again cos of x plus y. And the second row, third column element will be 0. Third row, it will be 0, 0 and 1. Friends, let's simplify further. So you will get cos of x plus y. As you know, this is again minus of cos x sin y plus sin x cos y, which is nothing but minus of sin of x plus y. The trigonometric formula we have to apply. This is 0. This is sin of x plus y, cos of x plus y. I just copy it as it is, and this is as it is. So this is our LHS. Friends, let's see what is the RHS of this equation. It is nothing but f of x plus y. So again, what does it mean? I just have to substitute x plus y. Wherever there is x, I have to put x plus y. And now let's write the matrix with that in mind. So we'll get cos of x plus y minus sin of x plus y. Please note, this is a different element and this is a different element. This is 0. Then in the second row, I have sin of x plus y and cos of x plus y. And this is also 0. And the last row will be 0, 0, 1. So this is my RHS. Now if you observe the LHS and the RHS, this is the LHS and this is the RHS, you will observe that all the corresponding matrix elements are one and the same. So what does this mean? This means that the LHS is equal to the RHS. So this is nothing but it is equal to the LHS. So therefore RHS is equal to LHS, and hence we have proved that particular equation, that f of x into f of y is equal to f of x plus y. Friends, the 14th question goes as follows. You have to show that the product of these two matrices is not equal to the product of these two matrices. So how do we show that? The only way is to solve these two matrices on both the sides and prove that the LHS is not equal to the RHS. So let's go ahead and do that. Let's first take the left hand side. So the left hand side is nothing but this. So let's do the multiplication very carefully. So the first row, first column entry. So it will be 5 into 2, which is 10, minus 1 into 3. So you will get 3 here. So 10 minus 3. Then the first row, second column will be 5 into 1, which is 5, and minus 1 into 4. So 5 minus 4. 6 into 2, 12, plus 7 3s are 21. 6 plus 28. So this is the product matrix. So if I simplify this further, I'll get 7, 1. This is nothing but 33, and this is nothing but 34. So this is my LHS. So if you again check the question, if you see this matrix is actually over here and this matrix is over here. So they have just rearranged the order of the matrices. So if I call this matrix A and B, you have done A into B on the left hand side, and they have done B into A on the right hand side. That's what they have done. So they wanted you to check whether A into B is equal to B into A. So in this case, it is not true. So matrix multiplication is not really commutative because AB is not always equal to B into A. So friends, now let's solve the RHS. So when we solve the RHS, it will be 2 5s are 10 plus 6. Then you will have 2 into minus 1 minus 2 plus 1 into 7, which is 7. Now let's go to the second row. 3 into 5, it is 15, plus 4 6 are 24. Then you have 3 into minus 1 minus 3 plus 28. So when I solve this further, I'll get 16, 5. This will be 39 and this will be 25. So if you see, the LHS was nothing but 7, 1, 33 and 34, which is clearly not equal to the RHS, because this is the RHS. As you can, why is it so? Because you can see the corresponding elements are not at all equal. So 7, 16, 1, 5, 33, 39, 34, 25, no way it is matching. So LHS is not equal to RHS and hence it is proved. Friends, the 14th second part is also very similar to the first part. We are given two matrices and we have to show that their product is not the same if their order is changed. So this matrix is first in the left hand side, but it is second in the right hand side. So when you change the order of multiplication of the two matrices, although it is the same two matrices, the product is not the same. So let's go ahead and prove that A into B is not equal to B into A. So for that, let's start with the left hand side. You can start with any side. So let us multiply it directly. So the first row, first column entry will be 1 into minus 1, which is minus 1, 2 into 0, which is 0, 3 into 2, which is 6. The first row, second column will be 1 into 1, which is 1, plus 2 into minus 1. So you'll get minus 2, plus 3 into 3, which is 9. Then the first row, third column will be 0, 2 into 1, plus 4 3s are 12. Now let's go to the second row. You will get 0 over here. Again you will get 0 and here also you will get 0. Let's go to the second row, second column. You will get 0 here, minus 1 plus 0. Now the second row, third column will be 0 plus 1 plus 0. Be very careful while doing the multiplication of the corresponding matrix elements. Now let's go to the third row. 1 into minus 1 plus 0 plus 0. Then in this third row, second column, it will be 1 into 1, 1, 1 into minus 1. So it will be minus 1 plus 0. Third row, third column will be 1 into 0, which is 0, plus 1 plus 0. Now let's simplify this further. So this will be 6 minus 1, which is 5. This will be 10 minus 2, which will be 8. This will be 14. This second row will be 0. This will be minus 1 and 1. Again in the third row you will have minus 1. This will be 1 minus 1, 0. And this will be 1. That's all. This is the left hand side. Now friends, the right hand side, let's do the multiplication. The first row, first column entry will be minus 1 into 1, which is minus 1, plus 1 into 0, which is 0. Again this is 0 into 1, so that is also 0. Now the first row, second column entry will be minus 1 into 2, which is minus 2, plus 1 into 1, plus 0 into 1. Now the first row, third column will be minus 1 into 3, which is minus 3, plus 1 into 0, which is 0, plus 0 into 0, which is again 0. Now let's go to the second row. You will get 0 into 1, 0, plus 0, plus 1. Second row, second column, it will be again 0, plus 1 into minus 1. So that will be minus 1 plus 1 into 1, which is 1. Now the second row, third column will be 0 into 3, which is 0. Minus 1 into 0 is also 0 and 1 into 0 is also 0. Now the third row, first column will be 2 into 1, which is 2, plus 3 into 0, which is 0, plus 4. Then the second row, second column will be 4 plus 3 plus 4. And then the third row, third column will be 6 plus 0 plus 0. So let's simplify this further. We'll get minus 1. This will be 1 minus 2, which is minus 1. This is minus 3. You have 1 here. 1 minus 1 is 0. This is 0. 2 plus 4 is 6. 4 plus 4, 8. 8 plus 3, 11. And this one is 6. So this is the right hand side. So friends, let us check if the right hand side is equal to the left hand side. Absolutely not. All the corresponding elements are different. Even if one corresponding matrix element is different, then the two matrices are not said to be equal. So as you can see here, they are completely different. So the left hand side is not equal to the right hand side, and hence we have proved the equation. The 15th question is that we have to find the value of a square minus 5a plus 6i, given that A is a 3 by 3 matrix. Now let us not get confused by a square. A square simply means matrix A multiplied by matrix A. That's all. And this is 5 into A. So it's a scalar multiplied with a matrix. And I is, as you all know, is the identity matrix. So since A is a 3 by 3 matrix, this will also be an identity matrix of order 3. So it'll be nothing but 1 0 0 0 1 0 0 0 1. and that is multiplied with the scalar 6. So let's go ahead and do that. So a square is nothing but a multiplied by a. So we'll get 2, 0, 1, 2, 1, 3, 1 minus 1, 0, multiplied again by a, minus 5 into again a. So it will be 2, 0, 1, 2, 1, 3. Let's be very careful when copying the values of the matrix. Let us not miss any number. Plus 6 into the identity matrix. So it will be identity matrix of order 3. This is the value that we are asked to find out. So friends, let's do matrix multiplication. So the resultant matrix will also be of the order 2 by 3. The resultant matrix will also be of the order 3 by 3. So let's start. 2 multiplied by 2, which is 4, plus 0 multiplied by 2 will be 0, plus 1 into 1. That will be the first row, first column. Now the first row, second column will be 2 multiplied by 0, which is 0. This will be 0, and 1 into minus 1 is minus 1. Now the first row, third column, it will be 2, and this will be 0, and this will also be 0. Both the entries will be 0. Now let's go to the second row. That will be 2 multiplied by 2, which is 4, plus 1 into 2, 2, 3 into 1, 3. Now the second row, second column, this will be 0, plus 1, and this will be minus 3. Second row, third column, 2 multiplied by 1, 2, plus 1 into 3, plus 3 into 0. Now let's come to the third row. 1 multiplied by 2, 1 into minus 1 into 2, which is minus 2, and this will be 0. This will be 0 minus 1 plus 0. Now the third row, third column will be 1 minus 3 plus 0. So this is the multiplication. Let's parallelly do the scalar multiplication of these two matrices also. So 2 multiplied by 5, 10, 0, 5. Second row will be 10, 5 and 15. Third row will be 5, minus 5 and 0. Plus, let's do this also. So 6, 0, 0, 0, 6, 0, 0, 0, 6. Now the next step is, let's simplify this matrix. So we'll get 5, minus 1, 2. Second row entries will be 9, minus 2, 5. And the third row entries will be 0, minus 1 and minus 2. Let's write the remaining matrices as it is. This will be this way, plus the identity matrix multiplied by 6. Friends, please note, you cannot add these two matrices because there is a minus sign before this matrix. So technically we have to subtract these two matrices. So let's not do anything now. Now friends, let's subtract the first two matrices. So 5 minus 10, which is minus 5, minus 1, 2 minus 5 is minus 3. Now let's come to the second row. You'll get minus 1, minus 7 and minus 10. The third row will be minus 5, minus 1, plus 5. So you'll get 4. Minus 2, minus 0 will get minus 2. Plus, let's write this as it is. Now let's add these two matrices. So you'll get 1, minus 1, minus 3. Minus 1 plus 0, minus 1, minus 7 plus 6, minus 1, minus 10. This is minus 5, 4 and 4. So this is the answer of the entire expression. We have to prove that a cube minus 6a square plus 7a plus 2i is equal to 0. Now what is the meaning of a cube? A cube simply means we have to multiply a 3 times. That's all. A square, as you know, you're multiplying a 2 times. So what we will do is, first we will find out a square, and then we will multiply that with a to get a cube. So it will be much better if we follow this approach. So first let us find out what is a square. A square is nothing but a into a. So let us write the matrix down. 1, 0, 2, 0, 2, 1, 2, 0, 3. So when we multiply these two matrices, we will get the first row, first column. So 1 into 1 plus 0 into 0, which is 0, plus 2 2s are 4. First row, second column. So 1 into 0 plus 0 into 2 is 0. 2 into 0 is also 0. So the first row, second column is 0. Then the first row, third column will be 2 plus this 0 into 1 will be 0, plus 2 3s are 6. This is the first row. So the second row first column will be 0 multiplied by 1, which is 1, plus 2 multiplied by 0, which is 0, plus 1 into 2, 2. Second row second column, this is 0, 2 2s are 4, plus 1 into 0, again 0. Second row third column will be again 0, plus 2, plus 1 into 3, which is 3. Now this is the second row completed. Now let's go to the third row. Now this will be 2 into 1, which is 2, plus 0, plus 6. Then the third row second column will be, this is 0, 0, 0. So all the entries are 0. Now the third row third column will be 4. This will be 0 plus 9. So a square is nothing but, let's simplify. 1 plus 4, 5, 0, 8 is the first row. Second row is 3, 4 and 5, and the third row is 8, 0 and 13. Now once we get a square, let us find out a cube. So a cube is nothing but a square multiplied by a. Now you can either write a square multiplied by a or a multiplied by a square. It will be the same. So we can try that out as a separate problem if we want later. So let us first write it down. Let me take it as a into a square. So what is a? 102, 021, 203 multiplied by a square, whatever we have got over here, which is 508, 345, 80 and 13. So let's go ahead and multiply. So the first row first column will be 5 plus, this will be 0, 2 8s are 16. Now the first row second column will be all 0. First row third column will be 8 plus 0 into 5, 0 plus 2 into 13, which is 26. Now the second row coming there, 0 5s are 0, 2 3s are 6, 6 plus 8. Second row second column, it will be only 8. Second row third column will be 10 plus 13. Now coming to the third row, 2 5s are 10 plus this is 0 plus 24. This is 0, 0, 0. So the third row second column is 0. And the third row third column will be 2 8s are 16 plus 0 plus 39. So this will be 21, 0, 34, 14, 8, 23, 34, 0 and this will be 55. Now in the next step, we have to multiply each matrix by the scalar. So let's do that. We'll keep this matrix as it is. 12, 8, 23, 34, 0 and 55. Now this minus sign, I'll keep it outside. It's better because otherwise I have to put minus everywhere inside the matrix. So it's better to keep one minus outside. So let us multiply this matrix by 6. We'll get 30, 0, 48, 12, 24, 30, 48, 0 and 78. Again, let us multiply this matrix by 7. We will get 7, 0, 14. Let's be very careful when we are doing this. 14, 0 and 21 plus this matrix again we have to multiply by 2, 2, 0, 0, 0, 2, 0, 0, 0, 2. If you see, this is just addition and subtraction of matrix. So we can club it in one step. Or if you want, you can take two matrices at a time and do it. What I'll do here is, I will just tell you how to do it in one single step so that it is easy for you. Now what we do is, we will have to club all these matrices along with the addition and subtraction. So it will be, the first row first column will be 21 minus 30 plus 7 plus 2. If you see, that's the first row first column corresponding elements. Now let's go to the first row second column. So that will be 0 minus 0 plus 0 plus 0. So I'm showing you all the steps so that you understand what is going on. If you are thorough with this, you can directly write 0 over here. Now let's go to the third row third column. It will be 34 minus 48 plus 14 plus 0. That's all. Now let's go to the second row. That will be 12 minus 12 plus 0 plus 0. Then second row, second column will be 8 minus, second row, second column will be 8 minus 24 plus 14 plus 2. Second row, third column will be 23 minus 30 plus 7 plus 0. Now the third row, it will be 34 minus 48 plus 14 plus 0. Then you have 0 plus 0 plus 0 plus 0. Then you have 55 minus 78 plus 21 plus 2. Now friends, all that is remaining is to simplify this matrix. If you see here, 21 plus 9 is 30. So 30 minus 30. Here you will get 0. This is nothing, but if you see 34 plus 14 is 48. So 48 minus 48. Now let's go to the second row. This is 12 minus 12, directly 0. Now here if you see 14 plus 2 is 16. 16 plus 8 is 24. So you have 24 minus 24. Then here if you see it is 7 plus 23, that is 30. 30 minus 30. Now the third row, if you see, it is nothing but 34 plus 14. 48 minus 48. This is 0. And so third row, third column will be 78 minus 78. So let us now simplify this further. So this 30 minus 30 will be 0, 0, 0. Now the second row will also be 0, 0, 0, and the third row will also be 0, 0, 0. So all the matrix elements are 0. That means this is nothing but the null matrix, and that is equal to the right hand side which we wanted. So hence we have proved that the LHS is equal to the RHS. In the next video, we will solve the remaining questions of exercise 3.2. So till then, take care. Bye.